All right, so let's say that we have a mass of 5 kilograms on a rough surface, and they ask, what is the highest force that we can apply before it starts moving? I know the mass, I know the G, I know the frictions, the coefficients of friction, and I'm asking for the force. I'm looking for the force. How do I start? Well, by knowing the mass, I can find the force due to gravity, which is mg. So in this case, it will be 50 newtons. So I managed to find the force due to gravity. What I can find second is I can find the normal force. How are these connected? Well, they belong on the y-axis, and we do know that the sum of forces on the y-axis is 0. How do we know? The object does not move. It is in equilibrium. So if I consider this to be negative and this to be positive, I have that normal force minus the force of gravity equals 0, meaning that the normal force should also be 50 newtons. So I found normal force. Now, the next thing I can do is find the friction. Now, the friction will be static. It doesn't move. It tells me so. How can I go from the normal force to the friction? Well, we know that the highest value static friction can get is the coefficient of static friction times the normal force. This is actually the link between a force on the y-axis and a force on the x-axis. This is how we move from the y-axis to the x, or we can go the other way around. So now I know that the static friction equals the coefficient times normal force. In our case, this is 0.2 times 50, meaning this should be 10 newtons. So now I found static friction. How can I find the force? Well, I know that my object is in equilibrium, means that the sum of forces on the x-axis is also 0, meaning force minus friction equals 0. That means that my force should also be 10 newtons. So for applying a force up to 10 newtons, friction manages to cancel out my force, and the object will not move. Now, if it moves with a constant speed, the problem is exactly the same, because for as long as there is no acceleration, the sum of forces on the x-axis will be 0. So either not moving or moving with a constant velocity is the same. Now, the same problem could be given in exactly the opposite way. If they could give me the force and say, all right, I'm giving you that the force is 10, and find what my mass is. So in that case, I would start from the fact that my force is 10 newtons. I would go backwards using the sum of forces on the x-axis being 0, and I would find the normal force. The static friction. From the static friction, so I would do this first, and then from the static friction, I would be able to find the normal force. I would go opposite and find that the normal force is 50 from this equation. And then, by the fact that I know that this is 50, using the fact that the sum of forces on the y-axis is also 0, I can find the force due to gravity here. This is 50, so this should be also 50. So I can go from the normal force to the force due to gravity. And if I know the force due to gravity, I can find the mass. So I would be able to go backwards, find the normal force, know what the friction is, from the friction find the normal force, and from the normal force find the gravity, and from gravity find the mass. Or we could do something else. They could give me the mass and the force and ask for the coefficient of static friction. So in this case, they could give me the mass, meaning I could find the force due to gravity. From the force due to gravity, I could find the normal force, and from the force that I have, I could find friction, and then by knowing friction and normal force, I would be able to find the coefficient, just because the coefficient of static friction is static friction over normal force. So there, we use the same procedure but with different order, right? So we can either go from gravity, normal force, friction, force, or from force, friction, normal force, gravity, mass, or from gravity find the normal force, from the force find static friction, and then from these two find the coefficient. It's the same thing.